Let's estimate flood probabilities in Edmonton via Calgary. Why do this? Well, we know where flooding has happened in Calgary before, and we can figure out which factors might have contributed to that inundation by developing a predictive model that describes how factors like topography, water behavior, or hydrology, etc., are associated with inundation risk. We can then apply that model to a city like Edmonton, which is similar to Calgary with a similar population and a river running through it, and predict where inundation or flooding is most likely to happen. So how does this differ from other approaches? Well, now many cities have used past flooding events to predict future flooding events. You can see here, this dark blue is the previous flooding events. Now, the built environment in growing cities is changing rapidly, so sometimes past flooding data isn't reliable even when it's available. We don't have flooding data for Edmonton, so we need to develop a model. How do we do that? Well, we collect identical data points for each city. Things about elevation, slope, land cover, hydrology, and then for Calgary, we already have inundation data. So we can compare these elevation, slope, land cover, etc. factors to inundation, whereas in Edmonton, we can't do that yet. For both cities, we develop fish nets, and each of these fish nets contain little squares, in this case 500 meter by 500 meter squares, which contain information about the elevation, slope, etc. of that small area. And that's an easy way for us to make comparisons when we're modeling. When we ran our model, we found that being full of impervious surface or having neighbors that are nearby and full of impervious surface is significantly associated with a lower likelihood of flooding because these are areas where there's significant runoff. So we held onto these variables. And then we also found that distance to streams that develop or water is associated with flooding risk, and elevation is associated with flooding risk. All of these variables were significant and have impacts on where flooding is most likely to occur, in this case in Calgary. Now, how do we know this? Well, we developed little training sets, many of these, to assess our accuracy. You can see here the blue and green areas are areas where we're correct, and they outnumber the orange and red areas. The other good thing is that the orange areas outnumber the red areas. The orange numbers are areas where we think flooding is going to happen, but it didn't. These are areas where we would have encouraged getting prepared. More false positives is better than false negatives when it comes to something as severe as flooding. What does this mean for a place like Edmonton? Well, we ran the model, and here's what we got. These white areas, again, low probability of flooding, purple areas a little higher. These low probability areas have more impervious surface and thus have more runoff. These are parts of the center city. And then running through it, you can see the river here. Riverbank communities are most likely to experience flooding, and then low-lying communities in those riverbanks are likely to experience flooding, and other parts of the city are likely to experience flooding in their own way. We should compare this to future floods to see if the model was accurate in its predictions, and then tweak the findings to be specific to Edmonton so that we can have a better model in the future. This model is great. We're very proud of it, but when we have more data, we'll be able to develop something that is specific to Edmonton, not just apply something from Calgary to Edmonton.